Hey Flow Devs, welcome back to the channel. Are you ready to level up your content creation game? Today I'm diving into something super exciting, building an AI-powered progressive web app that's going to change the way you create and manage content. We are talking about a killer stack here, Next.js for blazing fast server-side rendering, Tailwind CSS for stunning responsive designs without the hassle, and Supabase to give us a powerful backend that's a breeze to set up. And let's not forget Zustand for state management that keeps things clean and simple. In this tutorial, I will guide you step by step through the entire process from setting up your environment to deploying your app. Whether you're a seasoned pro or just dipping your toes into web development, you will find valuable insights and practical tips that you can apply right away. So grab your favorite code editor, fire up your terminal, and let's get started coding. Don't forget to smash that like button and subscribe for more epic dev content. Let's jump in. So first let's create a folder called content pwa. You can name it anything you want. Then drag and drop it in VS Code and you can use your favorite code editor. I'm using VS Code. Next open up terminal and we are going to create a new Next.js app. So in your terminal write npx create next app at latest. So it will install in root of this folder. So select the Next.js default settings and now you can see Next.js has been installed. Now let me show you what is going to be our folder structure. We got 6 folders in total inside the source folder. First one is our app folder that contains our pages and APIs. Next is the assets folder that you can find it in the GitHub repo defined in the description section of this video. Next is the components folder. Then we got the lib folder. Here we are going to specify our Supabase, server and client ports. Then we got the store folder and it is going to contain our Zustand states, and in the end we got the types folder that has the most common TypeScript types of our project. Now let's go to our tailwind.config.ts file, and in our Tailwind CSS configuration file we will look at how to set up your content paths, extend your theme, and integrate useful plugins like Daisy UI and the Tailwind scroll bar. Let's get started. First up, let's talk about the content property. This is where you define the paths to all the files that Tailwind should scan for the class names. In this example, we are scanning all JavaScript, TypeScript, JS6, TS6, and MDX files in the pages, components, and app directories. This ensures that Tailwind generates the necessary styles based on the classes you use in your project. Next, we have the theme property where you can customize your design tokens. Here you can add custom colors, spacing, fonts, and more. The extend keyboard allows you to add the default Tailwind theme without overriding it. For example, you could add a new color palette or custom breakpoints. Now let's talk about plugins. In this configuration we are using 2 plugins, Daisy UI and Tailwind scroll bar. Daisy UI is a component library that provides a pre-designed UI components, making it easier to build beautiful interfaces quickly. The Tailwind scroll bar plugin allows you to style scroll bars, which is often overlooked but can enhance your user experience significantly. Now let's go to layout.tsx file, and a global layout allows us to define a consistent structure of our pages, including headers, footers, and any global styles or components. This is essential for maintaining a cohesive user experience throughout our application. Let's take a look at our root layout component. We start by importing the interfont, our global CSS file, and the toaster component from Sonar. The interfont is important from Google Fonts. This allows us to use it throughout our application. Next.js makes it easy to include fonts, ensuring they are optimized for performance. We also import a global CSS file, global.css. This file is where we can define styles that apply to our website or our application. In the return statement, we render the HTML and body elements. The children prop allows us to pass in any nested components or pages. The toaster component from Sonar is included at the bottom of the body. This component will handle the toast notifications throughout our application. This is an example of how the toast from the Sonar works. Now let's go to globals.css file. At the top of our CSS file we have the Tailwind directives. These directives import Tailwind-based styles, component styles, and utility classes, allowing us to use them throughout our application. Now let's look at some custom styles we have defined. The .gr text class creates a gradient text effect using a linear gradient. The background clip property ensures the gradient is clipped to the text, creating a stunning visual effect. The dot-centered left class positions an element absolutely centering it vertically and slightly offset to the left. This is useful for creating a unique layouts. The dot-glass class creates a frosted glass effect using a semi-transparent gradient. This style adds a modern touch to your UI. The dot-selected class styles an element that indicates a selection, with a white background and a green outline. The important declaration ensures that style take precedence. The dot list item class applies a similar glass effect as before, while the dot active tab class uses Tailwind's apply directive to combine utility classes for an active tab state. Finally, the dot drop class adds a drop shadow effect to element, enhancing their depth and visual appeal. Next, let's go and create our authentication pages. So first, we are going to create a login page. So create a folder login and then page.tsx. So we are going to create a login page for our application using Next.js and Supabase for authentication. Let's dive in. Let's start by looking at the code for our login page component. We use the cookies function from Next headers to get the cookie store and create Supabase server. Inside the return statement, we render the login page with a form and an image. The login form component handles the login functionality, allowing users to enter their credentials and submit the form. We use Tailwind CSS classes to style the login page and its components, including the form and the image. The login form is centered on the page with a gradient logo and a link to the registration page. Now let's go to lib folder and we create an index.ts file, and we are going to create our Supabase client and server clients to handle cookies and discuss the difference between them. This setup will help you manage user sessions and perform database operations seamlessly. First, let's look at the imports we need for our setup. We import create browser client and create server client from the Supabase SSR package, along with the create client from the Supabase JS library and cookies from Next.js headers. Next, we create a Supabase client instance for use in the browser. The client will be used for making requests from the browser. We utilize environment variable to securely store our Supabase URL and anon key. Now let's set up the server client, which will manage cookies for session handling. Here we define a function that takes a cookie store and returns a Supabase server client. This client will handle cookie management for user session, allowing us to get, set, and remove cookies easily. Notice that we have try and catch blocks around our cookie operations. This is important because the set and remove methods might be called from server component, and we want to handle any potential errors gracefully. Now we are going to create our input component. So in the components folder, write input.tsx file, and the input component will allow us to easily create input fields with icons and error messages. We will use auto-animate hook for smooth animations and integrate it with React hook form for validation. Let's look at the code for our input component. The input component accepts several props, including an icon placeholder, text, input type, and validation methods from React hook form. These props allow us to customize the input field based on the context which it's used. Now let's render the input field and the associated icon. We apply several Tailwind CSS classes to style the input field. The input has a dark background, white text, and a green caret. We also add padding and rounded corners for our polished look. The icon is positioned absolutely to the left of the input field, providing a visual cue for the user. Next, we handle error messages that may arise from validation. The input field integrates with React hook form using the register function, which connects the input to the form state. If there is an error associated with the input field, we display it below the input in red text. Then we are going to our register page. So we are going to build a registration page. Let's start by looking at the code for our registration page component. It is more likely like the login page. So we use the cookies function from Next headers to get the cookie store, and we create a Supabase server client. Inside the return statement, we render the registration form along with the banner image. And next, let's go to our sign up form component, signupform.tsx. And next, let's look at the sign up form component where users will enter their registration details. Then we are going to render the component. And as you can see, everything is more likely like the login form in the components folder. Then we are going to create middleware.ts file that we are going to explore how to implement middleware in Next.js application using Supabase for authentication and session management. Let's jump right in. Middleware in Next.js allows us to run code before a request is completed, making it perfect for handling authentication. We will look at how to create a Supabase client, manage cookies, and check user sessions. Let's start by setting up our middleware function. We import necessary functions from Supabase and Next.js. We define our middleware function, which takes a Next request as an argument and initializes a Next response. Next, we create a Supabase client instance using the createServerClient function. We pass in our Supabase URL and anon key from an environment variable. The cookies object allows us to manage cookies for authentication. We define get, set, and remove methods to handle cookie operations. Now let's check user session. We do this by calling supabase.auth.getSession. This function retrieves the current user session, allowing us to verify if a user is logged in or not. You can add additional logic here to redirect users based on their authentication status. Finally, we return the response object. This allows the request to process any modifications we made. With this setup, your Next.js application can now handle user authentication seamlessly. Now, let's go and create the loading.tsx file. So we got the loading. We will be using Tailwind CSS for styling our loading component, which will be centered on the screen with a nice loading animation. This is essential for improving the user experience in applications where data fetching or processing takes time. Let's take a look at the code for our loading component. This component is a functional React component that returns a div element containing our loading animation. Next, go to our page.tsx file. And let's start by looking at the code, and then we import necessary components and libraries such as the sidebar, main input, top bar, messages, and create components, along with the server Supabase function from our custom library. Next, we use the cookies function from Next headers to get the cookie store and create a Supabase server client. We retrieve the user session using supabase.auth.getSession. If there is no valid session, we redirect the user to the login page. Inside the return statement, we render the chat interface using the imported components. The main structure includes a sidebar, top bar, message areas, a create button, and an input field for sending messages. We use Tailwind CSS classes to style the layout and apply dark background color to the entire page. The sidebar component displays the user's email and potentially other user-specific information. The messages component renders the chat history displaying messages sent by users. The main input component allows us to type and send messages. You can implement real-time updates using Supabase real-time features. Then let's go to our usestore.ts. Create a usestore.ts file in your store folder. Is going to be our Zustand states. Zustand is a small, fast, and scalable state management solution for React, and that makes it easy for manage global state without the boilerplate code, often associated with other state management libraries. Today we will create a simple store that manages the sidebar status, the current project, and the selected tab. Let's take a look at the code for our Zustand store. We import the create function from Zustand and define three separate stores: use sidebar, use project, and use tab. First, let's look at the use sidebar store. The store manages the visibility of the sidebar. The open state is initialized to false, indicating that sidebar is closed by default. The setOpen function toggles the open state between the true and false. Next, we have the useProjectStore. This store holds the current project state. The project variable is initialized to undefined, and the setProject function allows us to update the current project when needed. Finally, let's look at the useTabStore. This store manages the currently selected tab in the application. The tab state is initialized to chat, and the setTab function updates the selected tab based on user interaction. Now let's go to sidebar.tsx file, and we are going to create our sidebar component. Let's start by looking at the code for our sidebar component. We import necessary components and libraries such as the useSidebar hook from our Zustand store, various icons from React icons, and the client Supabase function from our custom library. We use the useSidebar hook from Zustand to manage the open state of the sidebar. The open variable represents the current state of the sidebar, and the setOpen is a function to update the state. We use the client Supabase function to create a Supabase client instance and fetch data from the database. We fetch a list of projects from the social table and store them in the list state variable. We also set up a real-time subscription to listen for updates in the social table and update the list accordingly. The sidebar includes several features, such as search, project management, and user profile information. The search functionality is implemented using the search menu component, which is conditionally rendered based on the open state variable. The project management section includes a button to add a new project, which opens a modal using the modal component. It also displays a list of projects using the list item component. The user profile section displays the user's email, account balance fetched from the billing table using Supabase, and the sign up button. Now let's go to our search menu.tsx file in the components folder. A command palette is a powerful UI element that enhances user experience by providing quick access to commands and navigation options. We will set up the search menu component, enabling users to search for exaggerate commands seamlessly. Let's take a look at the code for our search menu component. In this component, we manage two pieces of state, page and search. The page state determines which section of the command palette is currently visible, while the search state holds the user input for filtering commands. Next, we define our command items and filter them based on the user search input. We define an array of command items, each with a heading and a list of actions. This filter items function filters these items based on the current search input. Now let's render the command palette using the command palette component. Inside the command palette, we handle user input and actions. When the user types in the search box, the unchanged search function updates the search state. If the user selects an item, the corresponding action is exaggerated, such as logging out in this example. Now let's go and create list item.tsx component. So the list item component will display project details and social media icons when clicked. It will update the project state and navigate to the corresponding project page. Let's take a look at the code for our list item component. We use Zustand to manage the sidebar state and the project state. The setOpen function toggles the sidebar visibility, and the setProject function updates the current project details when a list item is clicked. Next, we define a handleClick function to handle click events on the list item. When a list item is clicked, we remove the list item class from any previously selected item and add it to currently clicked item. We then update the router to navigate to the project page and set the project state with the relevant details. Now let's render the list item and the corresponding social media icon. We conditionally render the appropriate social media icon based on the social prop. This allows us to display the correct icon for Instagram, YouTube, or X. This component allows us to display the project title styled with Tailwind CSS classes for a consistent look. Now let's go and create modal.tsx file in the components folder. The modal component will include fields for entering the project name and the description, selecting a social media platform, and submitting the form. Let's take a look at the code for our modal component. We use Zod to define a validation schema for our form inputs. The schema requires both the project name and description to be at least 6 characters long. If the validation fails, appropriate error message will be displayed. Next, we manage the local state and retrieve the user ID from Supabase. We use the use effect hook to fetch the user's ID when the component mounts, ensuring that we associate the project with the correct user. We also define a function to handle selection of social media platforms. When a user clicks on the social media icon, we update the selected platform and visually indicate the selection by adding a selected class. Now let's implement from the form submission logic. When the form is submitted, we create an object with a project detail and insert it into Supabase social table. If the submission is successful, we reset the form and close the modal. Finally, let's render the model and its contents. Then we are going to create our topbar.tsx file in the components folder. The topbar component will showcase the current project's title and the description, along with tabs for navigating between different sections of the project. Let's take a look at the code for our topbar component. We use the use project and use tab hook from Zustand to access the current project details and tab state. We define a function to handle tab selection and update the tab state accordingly. When a tab is clicked, we remove the active tab class from any previously selected tab and add it to the currently clicked tab. When we then update the tab state using the setTab function from Zustand. Now let's render the top bar and its contents. We apply several Tailwind CSS classes to style the top bar and its contents. The top bar has dark background color and rounded corners. On large screens, we also add a padding for spacing. The project details are displayed in column with a white title and a gray description. The tabs are styled using the tabs and tabs bordered classes, creating a bordered tab navigation. Next, we are going to messages.tsx file, and the message component will display chat messages based on the selected project. We will implement real-time updates using Supabase and style the chat interface using Tailwind CSS. Let's take a look at the code for our messages component. We define a state variable for storing messages and a loading state. We use the use effect hook to fetch messages whenever the project ID changes. To enable real-time updates, we subscribe to changes in the social table. Now let's render the messages in a chat format. We use Tailwind CSS classes to style the chat interface, including chat bubbles and avatars. Messages from the user and the bot are displayed on opposite sides of the chat interface for clarity. Then we are going to create main input component. We are going to create a chat input component in our React application. This component will allow users to send messages in a chat interface. Let's take a look at the code for our main input component. We use the use state hook to manage the text input state. Next, we define this handle submit function to handle form submissions. When the user submits the form, we prevent the default behavior and clear the input field. We fetch existing messages from the Supabase database using the project ID. If there are no existing messages, we handle that case appropriately. We create a new message object and push it to the existing messages array. Then we update the messages in Supabase and send the user's message to our chat API. Finally, we render the input field and send button. Then we got the API /auth. So we are going to create our API folders and files. So the first one is our authentication API. The provided code snippet is a GET request handler that processes an authentication code retrieved from Supabase. If the code is valid, we exchange if for a user session and redirect the user to the specified URL, API/chat. Now we are going to create our chat API. The provided code snippet is a post request handler that takes a message and a project ID from the request body, sends a message to the replicate API for response generation, and stores the conversation in Supabase database. This is a great way to add interactivity chat. Then we are going to create our generate API. The provided snippet is a post request handler that takes a prompt width and height from the request body, sends it to the replicate API, and returns the generated output. Next, we are going to our components folder and we are going to create a create form component. The create form components will include a form where users can enter prompt, username, and description. The component will then generate an image based on the prompt and displays it in the social media mockup. Users can also download the generated image. Let's take a look at the code for our create form component. We use Zod to define validation schema for the prompt input. We use React Hook Form to manage the form state and handle form submissions. When the form is submitted, we send the request to backend API endpoint with a prompt and desired image dimensions. The backend API generates the image based on the prompt and returns the generated image URL. We render different social media mockups based on the selected project type. We add a button that allows users to download the generated image. Next, we are going to create our upload button .tsx file in our components folder. The upload component will handle file input, read the uploaded image file, and update the avatar state in the parent component. We will use the file reader API to convert the image file into a data URL. Let's take a look at the code for our upload btn component. The handle change function is triggered when the user selects a file. We check if any files were selected, and if so, we create a new file reader instance to read the file as a data URL. Once the file is read successfully, we check if the result is a string and update the avatar state using the setAvatar function passed from the parent component. This allows us to store the uploaded image URL in a parent component state. Now let's render the file input element. We use Tailwind CSS classes to style the file input, giving it a border appearance and ensuring it fits well within the layout.